Hi students, welcome to all 4 learning chemistry classes. Today we are going to start session 24. In the previous session I have discussed about the balancing of redox reactions by ion-electron method, that's true particularly in acidic medium. Yesterday we have discussed 2 questions based on ion-electron method to balance a given redox reaction. In this session, let me go for the next medium, that is basic medium. So balancing of redox reactions in basic medium by using the same method, that is ion-electron method. Almost all the rules are same except one rule while balancing the hydrogen atoms. The remaining everything is same what we have learned in yesterday's session, that is balancing in acidic medium by using ion-electron method. So only the difference between these 2 medium is only the balance of hydrogen atoms. The remaining all is the same. Please concentrate. For this also, let me explain by taking one example. Please concentrate and write down along with me. Let me write the redox reaction to be balanced. Permanganate ion Mn plus MnO2, iodide ion to I2, OH minus on the arrow represents that you should do this, the balance of this redox reaction in basic medium. Same method I am using, students, ion-electron method. Just what we did yesterday's balancing of redox reactions. Here we have to fix the oxidation number of elements for which it has been changed. First we have to identify them. As usual, I am writing permanganate plus 7. We did the calculation yesterday. You should be in a position to write immediately. Iodide ion, monoatomic ion, charged ion itself is its oxidation state. So for manganese dioxide, for 2 oxygens -4, so manganese you should write it as +4. And for iodine it is a homoatomic molecule. For both the iodines you can write blindly as 0 as per our rules of oxidation states. Now we have to identify which species is reducing and which species is oxidizing. If you observe carefully, manganese is decreasing from +1 to +4. So there is decrease in the oxidation state. It means we can say that permanganate ion is undergoing a reduction. And iodide ion, where -1 is oxidation state and becomes 0. It means increase in oxidation state, nothing but oxidation. So our first step is we have to divide this redox reaction into 2 half reactions. Left side oxidation half reaction, just I am writing OHR, and right side we have to write as reduction half reaction. Let me write oxidation half reaction. I minus, write down students, I minus gives rise to I2, and reduction half reaction is permanganate ion will be reduced to manganese dioxide. Just now I have written both the half reactions. Okay, what is the next step? Our next step is we have to balance the elements except oxygen and hydrogen. That's the first step. Actually what we did even in the case of acidic medium and in the previous session. Same thing. So first let me do the balance of elements except oxygen and hydrogen. So 1 minus, okay, here I minus, here 2 iodines, so you should balance by multiplying this with 2. Okay, first step is over. Next step is balance of oxygen atoms. Same. In acidic medium, we have balanced oxygen atoms by the addition of H2O molecules on requisite side, where the number of oxygen atoms is less. Similarly, in the same way, here in the basic medium balance also, we have to add the requisite number of water molecules where the oxygen atoms is less to that particular side. Where exactly the less here, if you observe this equation, 4 oxygens are here on left side, 2 oxygens are on right side. 2 are less on right side, so you should add 2 H2O molecules on that. Here, there is no meaning of balance of oxygen because no oxygen is there. You can write as it is this step. Okay. Let me balance that equation with respect to oxygen. You please write down the same rule for this medium also, students. Balance the oxygen atoms by the addition of H2O molecules on requisite side. Okay, here 4 and 2. So I have balanced with respect to oxygen as by addition of 2 water molecules on the right side of that reduction half reaction. Okay. Up to now what I did, I have balanced the elements of oxygen and hydrogen, and I have balanced the oxygen atoms by the addition of H2O molecules. So next one is balancing of hydrogen atoms. There the difference is there between acidic medium balance and basic medium balance. Remaining everything is same in both of these two media. So let me write the theory part also. You please note down what exactly the difference is there while balancing of hydrogen atoms in basic medium from that of acidic medium. You write down, I will dictate it. I will write here also. Please copy it down. Write down, friends. Balance hydrogen atoms by the addition of, write down, by the addition of H2O molecules, by the addition of H2O molecules and add the same number of hydroxide ions on opposite side. I am repeating the statement. Please note it down. Balance the hydrogen atoms by the addition of H2O molecules and add the same number of hydroxide ions on opposite side immediately within the same step. Don't neglect. Please concentrate. Here hydrogens also should be balanced with water molecules, but at the same time within the same step you should add the same number of hydroxide ions on opposite side. Say for example, if you add left side the H2O molecules, you have to add the same number of OH minus ions on the opposite side, that is right side of the equation. Now I will do that balance by taking this equation. For this, no need write down as it is. No hydrogen, no oxygen, nothing. Concentrate, friends. I am balancing hydrogen here. This is the only important step what we should learn newly in basic medium balance. Now right side 2 into 2, 4 hydrogens. 4 hydrogens. Left side no hydrogens. Here I am balancing. Concentrate, friends. Right side 4 hydrogens, left side no hydrogens. So you should balance this with 4 H2O molecules. And I have added 4 H2O molecules for balancing of hydrogen. So I have to add the same number of hydroxide ions immediately on the opposite side. Yes, 4 H2O. You have to write it as 4 OH minus. Don't neglect immediately. Otherwise, there is a chance of forgetting addition of that and you will get finally the wrong answer. Don't do like that. Okay, concentrate. Once again, I will repeat the balance. Friends, please concentrate. How I am balancing the hydrogen atoms here. Please concentrate. I will repeat it. 2 into 2, 4 hydrogens. So, no hydrogens. So I have to add 4 H2O. Immediately on the opposite side, 4 OH minus. Don't take any chance. Please write down within the same step itself, here itself. And some students may get, they will think like this. Oh sir, H2O contains 2 hydrogens 2 hydrogens. Once again I will repeat, H2O contains 2 hydrogens, but only 4 hydrogens are there. Why don't we balance with 2 H2O on this side also? We will get wrong, because any H2O ionization give 1 H plus ion and 1 hydroxyl ion. You never get 2 H plus ions from water and normal ionization of water. So don't think like that. Here blindly follow the rules here. Don't think like that. You will get wrong answers. 2 into 2, 4 hydrogens. So you should balance with the 4 H2O, and immediately on the opposite side you have to add 4 OH minus, and you have to further simplify the equation once again within the same step. That is the major importance of balancing in basic medium. If you observe that after balance of hydrogen atoms here 4 H2O and 2 H2O, you can simplify that just like algebraic equation by bringing 2 H2O to this side, and finally I can write here 4 minus 2, 2 H2O, MnO2 plus 4 OH minus. So this is how to balance hydrogen atoms in basic medium. The remaining, the next step, those 2 steps are same what we have learned in the previous session. Please note down, students, I will go for the next step. Here I am going to rewrite the equations for further simplification. Okay. Meanwhile, you finish up the final step. MnO4 minus 2 H2O gives rise to MnO2 plus 4 OH minus. Even one single unit charge or positive charge, if you written wrong while moving from step to step, you will get wrong answers, friends. So one should be very careful while writing step to step the equation is. Okay. Now we have already balanced elements except oxygen, hydrogen, oxygen and hydrogen also. Now our next step is to balance the charges in both the reactions. How we are going to balance the charges? By the addition of electrons on the requisite side. Let me do that. Take this equation. Right side 0, I2, neutral molecule. Left side 2 ions, minus 2. So balance of charges should be done only by the addition of electrons. Don't forget about that. If you add 2 electrons here, this side also becomes minus 2. So I am going to add 2 electrons to the right side of the equation. Yes, with respect to charges, now this oxidation half reaction is balanced properly. Now come to this. Let me do. Here I am going to write. Left minus 1, water is neutral, 0. Right side 0, this is neutral molecule, and minus 4. So you should add 3 electrons to this side, then also it becomes minus 4. So if I add electron to this side, you never get minus 1, minus 5, minus 6, minus 7 like that. So you should add this side only. So how many electrons I have to add on the left side? 3 electrons. Let me add here itself 3 electrons. Yesterday, while explaining the balance of charges, I have told you one important aspect here. If you add on right side of the first equation, you have to add left side of the second equation. Otherwise, it is wrong what you did. Okay. Now, right side, this is left side. Okay. Now, it is correct only. No problem. You can check yourself at this step. No problem. Now, what's our next and final step? What we have to do to get the final balance of the redox reaction? Right. We have to equalize the number of electrons in both the reactions. Again, 2, 3 at combination. So, multiply this with 3 and multiply this with 2 and add the left to left and right to right, reactants to reactants and products to products to get the final balance of redox reaction. Now let me multiply this and add both the reactions. I am going to add after multiplication within the same step. You please concentrate, friend. 3 I am multiplying, 6 I minus. Reactants are over. Now I will take the reactants of second equation. I have to add. Multiplying 2. So 2 MnO4 minus 2 into 2, 4 H2O plus 2 into 3, 6 electrons. Okay. Now I am going to add, after multiplication, products to products in both the half reactions. 3 into I2, 3 I2, 3 into 2, 6 electrons. 2 MnO2 plus 8 OH minus. Electrons should be cancelled out, otherwise again you came to a conclusion that you did mistake. Exactly cancelled. And first let me write down permanganate. Okay, 6I minus. Okay, no water molecules on both sides. Okay, you can write. Okay, next 2 MnO2, 3 I2 plus 8 OH minus. I think this is the final balance redox reaction. Let me check with respect to manganese atoms. 2M and 2M. Iron atoms. 6I, 6I. Ox6. 2 into 4, 8 plus 4, 12. Here 4 plus 8, 12. Next hydrogens. 8 and 8. Close. Now let me check the charges also. Minus 2, minus 6. Minus 2, minus 6. Total minus 8 and left side. Leave it. 0, 0, minus 8. So charges also balanced properly. So this we can come to a conclusion that final balanced redox reaction, what we did in basic medium with the help of ion electron method. Students, we are doing many steps. In the previous session, the entire session I have solved only 2 questions. Today's session also I am going to solve, I think, maybe one more question. And tomorrow and next session, I think next session, I may go for one more model, oxidation number method. Maybe it takes the same time. But after finishing off all the 3, if you go for objective approach in JEE advanced or mains exams, whatever may be the competitive examination, you can solve all these things within 1 minute, less than 1 minute. Once if you are able to and get the knowledge of all these rules, that is in both acidic medium, basic medium, and the next method what I am going to teach you in the next session, oxidation number method. With the help of these 3, you can solve within the 1 minute or sometimes within 10 or 20 seconds also you can get the final form. I will teach you after completion of this, not now. You please finish off this and then I will go for one more question based on basic medium balance. Okay, students, let me go for one more question. This time I am going to take this one. First one. Phosphine, pH 3. Hypophosphite ion. This is basic medium balance. And let me write the oxidation numbers first. 0. For this phosphorus -3, and for this phosphorus -4 plus 2 goes to +1. Let me check whether this is correct or not. +2, -4, -2, yes, +1, no doubt. -3, +1. Here there is a specialty for this equation. Same phosphorus is undergoing oxidation, increase in oxidation number, and undergoing reduction, decrease in oxidation number. Both oxidation reduction takes place on the same element. That's why you can call this equation as a disproportionation redox reaction. Okay, already we have discussed about that. Now let me split into 2 half reactions. Now we are having all the rules to balance the reaction. Please follow step by step. But let me write oxidation half. I am writing heading also. P4 gives rise to H2 PO2 minus. Next, reduction half reaction. P4 gives rise to PH3. Let me balance the elements oxygen and hydrogen first of all. Phosphorus is there. P4, so I have to make it as 4. Here also P4, I have to write here as 4. Yes. Now I have balanced the phosphorus in both the half reactions. Next, we have to go for the balancing of oxygens. Oxygen should be balanced by the addition of water molecules. Here no water molecules, here no oxygen, here 4 into 2, 8 oxygens are there, no oxygen, so it should be balanced with 8 water molecules on left side. So P4 plus 8 H2O gives rise to 4 H2 PO2 minus. Here there is no oxygen, so you can write as it is. Now, the next step is balancing of hydrogens. Get ready. Right. Let me balance. Let me count. I am taking this equation. 8 into 2, 16. Here 8. 8 to 2, 16 hydrogens. Here 8 hydrogens. So 8 are less on this side. Now I am going to balance. You please concentrate. 8 H2O. I am going to write like this. 4 H2 PO2 minus. Okay. 16, 8 is less on this side, so you should write 8 H2O. Immediately on opposite side, you have to add same number of OH minus ions. Okay, I did the balance. Here, I am writing this equation. P4, 4PH3. Okay. Right side 12 hydrogens, left side no hydrogens. So you should balance this with 12 water molecules immediately opposite side, 12 OH minus. You have to add like that. Okay. Now we have to further simplify this equation. Okay, 8 water molecules can be cancelled out here. So P4 plus 8 OH minus plus 4 H2 PO2 minus. This is the equation. Here there is no further simplification. Directly you can write P4 plus 12 H2O gives rise to 4 PH3 plus 12 OH minus. So I have balanced the elements except oxygen, hydrogen, and then hydrogen also. Let me check here itself, no problem. And what is our next duty? We have to balance the charges. Okay, let me do that. Here total charge is minus 8 on left side, minus 4 on right side. If you add 4 more electrons on right side, so it also becomes minus 8. So let me add 4 electrons to this side. Balance. Here coming to minus 12, here no charge, so you add 12 electrons to this side. So it will automatically balance. And I have balanced the charges. So what is our next step? We have to multiply with suitable integers to equalize the number of electrons in both the half reactions. 12 electrons, 4 electrons. Multiply this with 3 and multiply this with 1. No problem. A suitable integer is sufficient. So I have equalized as 12 electrons on both the reactions. Now I have to multiply and I have to add reactants to reactants and products to products in both the half reactions to get the finalized equation. Please concentrate, I will do here. Please note it down. Okay, students. Let me write down here to balance. After multiplication, direct. Here. Left to left, right to right. 3p4 plus 24 OH minus. Now left of that. P4 plus 12H2O plus 12E minus. Now right side, 3 into 4, 12H2PO2 minus and 4BH3 and this 3, 12 electrons, okay, and this one here it is 12 OH minus. 12 electrons should be cancelled out. Okay, write down, students, write down. I am going to write final equation. 3p4 p4 4p4, okay, 12 H2O I am writing here, okay. Before that 12 H2O, here 24 hydroxide ions, concentrate, here 12 hydroxide ions. Bring that 12 to this side, 24 minus 12, 12 OH minus. Okay, left side is over. Then I will go for right side. Let me write first 4pH3 plus 12H2PO2 minus. Now this is final balanced, but there is a common term that which can be cancelled out throughout. 4 I can cancel out. P4 plus 3H2O plus 3OH minus PH3 plus 3H2PO2 minus. This is the final balanced redox reaction. Let me check phosphorus. Okay, balance. Oxygen 3 plus 3 6, balance. Hydrogen 6 plus 3 9, 9, balance. Charges -3, -3, both sides. This is final balanced redox reaction. So moreover, the same phosphorus is undergoing both oxidation and as well as reduction. So you can call this as disproportionation reactions. Okay, please note it down. Meanwhile, I am going to explain here about the charge balance once again. If you understand this, please note it down. While doing the charge balance, you can check yourself. You can check yourself whether charge balance is proper or not. Of course, all these are atoms you can easily balance. Only the confusion is about balancing of charges. So, while balancing charges, I will know how to check. If you add electrons to the left side of first reaction, but the addition should be done for the next reaction on right side, because I want to introduce one new concept here. Don't forget this, very very important. Actually, usually people used to teach on the first day itself. No, my style is different. After completion of 3 or 4 equations, I used to give that data. Here I am equalizing electrons, students, to balance redox reaction. What do you mean by that exactly? It is the number of electrons lost by reductant should be exactly equal to number of electrons gained by oxidant in the balanced redox reaction, such that there will be no net electrons that we have to observe in the final equation. No electrons should be there if it is properly balanced redox reaction, because the number of electrons lost should be exactly equal to number of electrons gained. Which is going to lose electrons? Reducing agent. Reducing agent is going to lose electrons. So, number of electrons lost by reducing agent should be exactly equal to number of electrons gained by oxidizing agent. Here I am writing the statement with this. Number of electrons lost by reductant should be exactly equal to number of electrons gained by oxidant, means oxidizing agent. This is the perfect concept of balancing of redox reactions, which can be more useful in second academic year in electrochemistry while solving some questions. Okay, students, with this I am going to conclude this session. Now the next session I will go for oxidation number method. Thank you.